My name is Warner Chavez. Happy to be your host. Allow me to introduce myself. I've been a SQL DBA and consultant for about 10 years now. I used to work as a level 3 database administrator at Hewlett-Packard. I am now a principal consultant out of a managed services and consulting company called Pythian in Ottawa, Ontario. I also happen to be an MCM for SQL Server, and I am very proud to be a Microsoft Data Platform MVP. If you want to reach out on Twitter, feel free to send me something at warchav. If you want to shoot me an email, feel free to use warner@sqlturbo.com. That is my personal blog. And if you want to check our company, and we also have a pretty heavy tech blog in the company site, is pythian.com. All right, so let's jump into the agenda for today. So the topic is going to be to discuss SQL Server baselining, and we're going to do it based around the PAL tool. Okay, so the PAL tool is called Performance Analysis of Logs tool. It's a free tool. We'll go into all the details about the tool later today. The cool thing about it, of course, is that it's free and available, but it has some sweet features that I like that give me a lot of flexibility in my work. So that's why we're going to go through it today. So we're going to talk about some basic baselining concepts. We're going to talk about PAL. We're going to talk a little bit about what are the Perfmon counters, my fundamental preferred Perfmon counters that I use when I'm baselining a system or troubleshooting an issue. We're going to talk a little bit about more specific type of counters that we could track for different type of SQL Server issues. And of course, we're going to do some demos. So I'm going to show you guys the tool, how to work a little bit with it, and I'm going to show you some stuff that I've done thanks to PAL and some of the analysis that I've done on actual real scenarios that I've used PAL as my helper tool to get those done. All right, so hopefully my objective personally is to give you guys ideas of how you can use this type of tool or other tools that you might have in your arsenal for the day-to-day performance analysis type of scenarios that we face as administrators, right? So first of all, just for, to cover everybody in the audience, if you're not familiar with the concept of baselining. So baseline is a snapshot of system behavior at a given point in time. So anytime that you just capture, like I said, like a snapshot of system behavior, that is a baseline. So a baseline doesn't necessarily just apply to software. A baseline pretty much applies to any type of system that you can measure, right? So you could have a baseline of how a plane is functioning. You could have a baseline as to how a robot in a factory is functioning. Anything that you can measure and you can assign actual numerical values is something that is baselineable, let's say, okay? So in our case, our baselines for what we do, since we're database administrators, is that we're trying to collect numeric values that represent the work that is being done by either the hardware or the software in our servers, right? So even if it's physical, regardless if it's virtual, baselines are always very, very important to collect. And we don't only want to collect stuff at the server level, so more like operating system style type of information, but we also want to collect information, in our case, very, very specific to SQL Server, right, which is what we're all here to talk about. So it's important to have baselines. Why? Because they get you out of many different situations and issues, because they serve as comparison points of performance. So in the abstract for this session, I mentioned the classic scenario of, somebody giving you a call and saying, hey, so-and-so, this server is kind of slow today, and people think it's the database. And then people, a lot of times, don't even give you any more detail than that, right? This is the situation where you can actually, if you have a baseline, you can say, like, wait a minute, what exactly is slow today? You can actually pull up, let's say, numbers from last week and compare to the numbers from today and be like, actually, yeah, the CPU is a little bit higher than usually is around this time, and it gives you something to go by, right? Same with to do before or after type of analysis and so on. So anywhere where you can use numerical values as comparison points is a good situation where you can pull out your baselines and help you with analysis for that. So like I said there, it can help us detect changes, it can help us spot trends. It can help us spot anomalies in our servers as well. Okay. So baselining can be done in many different ways, but in this session we're going to focus on two tools that will be ready available for anybody in the whole wide world. So Perfmon number one. So if just in case you're not familiar with Windows Server, even though if you're joining this chapter and you're a junior DBA, now I think it's a great actually a good session that you joined today. But just in case, so Perfmon is the performance monitor that comes included in Windows Server. For all the other hardcore DBAs that are in the session today, this is going to be really obvious, but I just have to cover it. So Perfmon just basically collects performance counters. So basically it's an object that exposes a numerical value related to a facet of its behavior. So for example, we have CPU and the percentage of processor time, right? So the CPU is the object, the percentage of processor time is the counter, that facet of the behavior, and then it gives you a value, right, of what that percentage actually is. So this is not an intro to Perfmon type of session, but it's good to cover that. And then PAL, which is the performance analysis of logs tools. And what PAL does is that it helps us create different templates of counters that we want to capture. And once we actually capture them, PAL also will help us analyze them and make some nice charts to share with people. Because a lot of the times the visual really helps make analysis easier to communicate and just faster, because our eyes, our visuals are very quick to spot like trends or similarities, as opposed to having just a huge table of numbers and try to spot trend or similarity with that, right? There are third-party tools as well, just like our sponsored SolarOne. There are some great third-party tools that can help you with the troubleshooting, that can help you with the baselining as well. Obviously, in this case, we're just focusing, like I said, on something that will be ready, available for everybody. So that's why I want to show you Perfmon plus PAL. And something else that is out of scope for this session, but you definitely have to think about when you are doing any baselining or you're responsible for any type of production SQL Server, is that the DMVs as well are a very powerful baseline tool. And I not only mean a baseline in this case purely from a performance perspective, but it's important, even though it's not covered and not in scope for today, it's important that you also capture a baseline of your configuration, right? So this is not something that we're going to cover today. I'm just covering right now how I see baselining as a whole for SQL Server. So I want to make sure that you also take away from this that configuration itself is very important to baseline, right? So let's say I've seen, for example, issues where suddenly there's an issue with the server, and we go in and we check, let's say, all the values that come out of SP configure, and turns out that somebody put a value of max worker threads to, let's say, 300, right? And it's like, oh, that's kind of weird. Why would somebody hard code a value of 300 for a setting like max worker threads, right? The default is 0, which means to just let SQL decide based on how many cores and how they're configured when it starts up, right? So it's kind of like weird. And then in that type of situation, you're like, well, has this always been the case? Is this actually the cause of my issue right now? So even though we're going to focus on performance today, keep in mind that having a baseline of configuration is very valuable for a lot of troubleshooting scenarios as well, okay? So let's talk about some of the useful counters that I like to capture for regular operating system and for our SQL Server itself. So CPU, definitely just the regular processor time percentage, how much time is my CPU actually busy. It's probably the easiest one to correlate to a performance issue, right? If you see that the more it gets closer to 100, the more you probably have an issue. A lot of times people obsess with it, and they want to see this being super low all the time. I don't really worry about it unless I see something like 80% or so over a sustained period of time. If you show me like a server that is like always at like 50% CPU, I don't think I necessarily worry about it. Because I mean, you're paying for CPU power, right? SQL Server itself is licensed by cores. You don't want to have to, a super idle system where you overpaid half of your cores just because you wanted to have, low CPU. So something else, especially on machines that might not be 100% dedicated for SQL, is to keep track of the actual processor time that SQL Server itself is using up, right? Because sometimes we find a situation where, oh, it wasn't SQL Server, the database engine itself, the one that was causing issues. It was, let's say, DTXEC, right? It was an SSIS package that went crazy, or it was a report server, report server.exe, the one that was causing all the CPU burn, or even I've seen situations even where the antivirus service was the one that was like going nuts because somebody forgot to set the exclusions on like data files and backups and whatnot. So you definitely want to make sure that you're not only checking to see if the CPU is high or not, but not by default assume that it's always SQL Server that's going to be the culprit. All right. Network, what you want to make sure on the network is, number one, how much data is flowing to and from the network, because you want to make sure that your network card is not being saturated. So this is not something that is super common unless there's like some sort of process or client or a link server or some SSIS thing that is trying to like literally move gigs of data from your SQL Server over to a client. So usually if you see something like that, that is really points to bad design or bad data integration somewhere down the line. And then you want to also track just to see if there's errors in and out of packets. This could be many things. This could be, an issue with a network device in the route. It could be an issue with the driver. But it's good to figure out if you're having that type of issue, because then it might be the, the TCP type of retries that have to happen over and over are the cause of possible latency as well. So those are the really main things that I look for on CPU and network. So like I said, so for the processor time percentage, I would say it's, and again this is my opinion, that to avoid just sustain over 80%, that's when you really should take a closer look at it. For the SQL processor time, make sure that it's not other apps that are actually starving SQL of CPU. For the network, if you know your NIC capacity and the capacity of the link, then make sure that you're actually not going all the way to the capacity, and you could be just saturating the network card. And you want to have obviously the errors in and out per second as close to zero as possible. So as far as disk, so we can track disk reads, writes, bytes per second, and that would be what is usually just considered disk bandwidth. So how much data is flowing per second to and from a disk device. Track disk reads and writes per second. So how many operations happening per second? This would be a more commonly known as just an IOP, right? So a lot of the times we see people just advertise or discuss their disk devices based on IOPS, which is a very incomplete definition. If somebody says, I have a disk that can do 1 million IOPS, that on itself doesn't really say much, because we need to know how much data does that 1 million IOPS mean, how big were each operation was, and we need to know how fast it was done, right? So that's where you want to do track the third counter there, which is disk seconds read and per write. So how long does each operation take? In my opinion, that last bit, the latency, how long does each operation take, is usually the biggest smoking gun type of counter for disk issues, right? Because you can get into a debate over how many IOPS something should be pushing or not, and then your storage admin is going to say like, oh yeah, our SAN can do way more IOPS than that, or they can be like, oh no, that's SQL Server that's throwing too many IOPS or whatever, right? So you can get into kind of debates about hardware, about IOPS and about bandwidth, but having high latency is very undebatable, right? You're either returning my operations fast or you're making them slow. So it's a lot easier to just, like I said, identify issues based on latency. For RAM, I would say track pages per second, though that's a value that's kind of hard to actually say what's good or what's bad. That's one of those where I usually recommend you baseline it and see if it deviates or not from when you had a healthy system. Track how much you're using of the page file. Obviously, if you're using a lot of the page file, it usually means that you're probably starved on memory. And the best counter I found for quickly looking to see if SQL Server's got some memory issues or memory pressure is to check the page life expectancy, which is how long are the pages staying in memory. A very popular SQL counter used to be the buffer cache ratio. I've just stopped tracking it for the most part because I found way too many situations where the server was definitely going through memory pressure, but due to things like the read ahead of SQL Server, the buffer cache ratio always stayed at a very high, above 95% type of value. So I found that over time I just find it not as useful to really track an issue down. So I've stopped mentioning it at all except to say this, that I don't track it anymore. All right, so the bandwidth, you definitely want to baseline the bandwidth and make sure that what you're actually consuming is below what your I/O subsystem capacity is. Otherwise, obviously, if you have your storage admin says that the SAN can consume about 1 gigabit per sec of your storage bandwidth and you're already at that, then you probably want to start having a capacity planning conversation. Same with the IOPS, you want to baseline it to make sure that it makes sense to what your actual capacity is. Latency, usually, less than 5 milliseconds is ideal. From 5 to 20, it really depends if the workload is very sensitive to latency or not. Anything that is bigger than 20, I always flag it as an issue and just tell people that it's something that they should be looking at. Another counter that is popular per disk, but that I didn't put it here, is the average disk queue length. And the reason why is because queuing or analyzing by the queue length is good if you know how your backend is set up, because the recommendation is usually about 2 times the amount of spindles should be your average disk queue length, and over that it might be an issue. But then you have to really know, like, okay, but how many spindles is in my backend, right? Is your SAN admin able to answer pretty definitively how many actual physical things are spinning or cards are being written to? It's quite a complicated counter to really analyze definitively without much of debate or ambiguity. So I usually don't even look into it unless I know exactly how the backend is set up. And RAM, like I said, yeah, the pages per second, baseline it. Page file percentage used, I'd say it should be always less than 10%, just because anything above that, a SQL Server machine should not be heavily dependent on the page file. If it is, then you probably have a bigger issue that you should be looking into. And the page life expectancy, the usual rule of thumb I use is, you divide the RAM by 4 and you multiply that by 300. Don't do just the 300 like we used to do back in the SQL 2000 days, because that's just too low for the amount of RAM that we have nowadays. And if you do have a server that has multiple NUMA nodes, do this per NUMA node to make sure that everything looks good. Okay. For virtual machines, it really depends on what your hypervisor is. So both Hyper-V and VMware expose some counters to the guest system. Usually you have to install, let's say at least on VMware, I'm pretty sure you have to install like the VMware tools so that those counters are visible on the guest. You want to always track pretty much the same counters we just mentioned for a normal machine, And if you do have those counters exposed on your guest, you could track VM-specific ones. Some of the VM-specific ones that, they have different names in Hyper-V and VMware, but usually they tell you like how much memory is mapped to the guest. So in case there's no hard committing of memory to the guest, you want to know, for example, you have a VM that's 32 gigs, but right now it might not have 32 gigs mapped on the host, right? It could be a smaller amount, so that's something you want to know. Memory ballooning, so is the hypervisor trying to reclaim memory from the different guests? What's the CPU speed I'm getting on the host? Does it match the CPU stock speed that I'm supposed to be getting from the model of the chip I have, or am I getting power down clocked because it's set to some power saving or things like that, right? And finally, for example, the CPU wait time. So when I need the CPU, am I waiting for a long time for the hypervisor to give me the CPU, which is something that happens when people just abuse the concept of virtualization, and then they just buy a 3-node VMware cluster, and then they put 300 VMs on it and just keep piling and piling on based on storage and not really look at how much overload they're putting on the real host. So this is something that is very common, by the way. So watch out just for things like that. And if you don't get them exposed, just while we're on the topic of virtual machines, if you don't get them exposed to the guest, just talk to your VM admin. If you have access to vCenter and you can actually see these things on your own, that's great. If you don't, then ask to get read access to it. There should not be any type of issue with getting read access, because you can't screw anything up if you only have read access, and it's very debatable that you should not be able to see this, right? You should. So feel free to ask that you need read access to read all these values from the hypervisor. So let's talk about SQL Server itself. So we talked a little bit about stuff that we want to track operating system-wise, hardware level-wise. Let's talk about SQL. So batches per second, I always track it and I baseline it because it's an indicator of load. You have to track it along with transactions per sec as another indicator of load, just because not every batch is going to be a transaction, right? So if you're just doing a select, it's not going to count as a transaction per sec, but it's going to count as a batch per sec. And then if, let's say, you would baseline both values and you found that, your transactions per sec just, let's say, was 100, and then you start having some sort of issue, and then you go and look, and you see, oh, I have like the same batches per second, but now my transactions per second have jumped to 400 or 500. Well, then it means that the nature of your workload has changed and is now a lot more write heavy, right? So tracking both is valuable in itself, because it can also tell you, like I said, when your workload has changed, and maybe you were running a system that wasn't as optimized for writes as it should now, because again, the workload has changed, right? I try to track connections per second, as a baseline as well, just to see how many connections we usually keep, because again, it might be that one day you have an issue and you go in and find, and suddenly it's like, oh, there's a ton of more connections than usual. What's going on? Maybe there was like a new software release that has an issue with just leaving connections alive and so on, right? Compilation or recompilation per second, I usually baseline it as well. It's a good indicator if you're burning a lot of CPU, just compiling or recompiling things. If you have memory grants pending, it's a good sign of memory pressure as well. So that's another good one to capture in general for SQL Server. Lock timeouts per second. If you have concurrency or blocking issues, that's a good one to capture as well. And deadlocks, it's a good one to capture, because any deadlock that you see in your system, it probably needs troubleshooting, or at least give it a little bit of attention, right? It might be that just one deadlock is not a big deal, but it means something. It means that there's probably either some transaction code or some indexing that could be better or something like that, right? So these are just the general ones that I would suggest to track in the vast majority of situations. But I mean, SQL Server has many different type of features and scenarios and workloads that can come up, right? So let's say, for example, if you're working on a really high concurrent environment where you are mandated to squeeze every single ounce of performance out of the server, well, then maybe you want to track latch-related counters. See if you're actually getting significant amount of latch waits per second that translate into actual real waiting time. And, you know, maybe you want to use something like in-memory to remove that latch wait. If you have issues with fragmentation, well, you could track page splits per second, and then you might discover that there's something happening at a given time of the day that is causing the most fragmentation. That'll help you drill down into what could be the root cause of the issue. If you're tracking connectivity issues, then, you know, like I said, we always track connections, but maybe you want to track also login and logout attempts per second and see if, you know, there's some deviation from the baseline again. If you're having some tempdb issues, like the tempdb is super overloaded, you want to figure out where that's coming from, you could track the work file creations and work table creations per second, which, like I said, just track operations that are happening inside tempdb. If you're using availability groups, it's a good idea to track the throughput of how much data we're pushing through the availability group transport. How fast are we hardening the log on, like, the secondaries, for example? How fast are we actually doing the redo after the log is hardening on the secondaries as well? And there's counters for everything, right? So again, this is all dependent on scenario, and as DBAs is good. If you know, like, for example, that in your shop one of your more important SQL servers is using availability groups, then get yourself familiar with these performance counters, right? Know the type of information that you can get from them, and obviously add them to your baseline, and you can use something like PAL for it. And this applies to all the other features, right? If you are heavily starting to use column stores, there's a lot of performance counters related to column stores. If you suspect you're having some transaction log slowness, you could track counters related to writing and waiting on the transaction log. You could track counters related to memory, resource governor, plan cache, etc. Right? So it's all dependent on the type of situation that you are dealing with. Okay, so how does the PAL tool help us? Well, first of all, like I said, I wanted to focus on something that anybody in the world can use. So it's a free tool. You can find it on Codeplex. Just go to pal.codeplex.com. It processes, analyzes, and charts Perfmon counter traces. So once you have the file generated by Perfmon, you just give it to PAL. PAL takes it in. You can apply a template to it, so PAL knows what type of thresholds to look for. It'll start reading the whole thing, and then it'll give you a bunch of charts and an HTML report. It supports many different products, so even though we're going to be using it for SQL Server here, it supports, I believe, probably all of major Microsoft products. Like, it has a template for Exchange, a template for SSIS, a template for BizTalk, and so on, right? And then the nice thing about it is that it's highly customizable. So even if there's no template that applies to your needs, let's say, for example, that you want to track the stuff that is related to in-memory, and none of the PAL templates are tracking those in-memory counters, there's nothing stopping you from modifying the template and just saying, hey, this is my in-memory counter template, and you save it, and then you can reuse it as many times as you want, right? So some of the functionality that we get from PAL, we can export from a templates. We export the Perfmon XML file that we can then consume with Perfmon and set up the trace that way. It supports inheritance between templates, so you can make a basic system template, and then from that do a basic SQL template, and then from that have a bunch of different really specific SQL templates that will inherit from your basic SQL template. You can edit it, like I said, to customize for your needs, what counters do you want to track. You can edit it for the threshold, so if you want to have change the threshold to be higher or lower, you can do it as well. It can process one or more files, so you can have a queue, basically, that will just generate a bunch of different analysis on different files. You can actually, if you have a file that covers many days, but you only want to analyze one day, you can focus on a specific time span. We'll see the HTML report as part of the demos. So I'll show you what the HTML report looks like and the alerts and averages and max and mins, how it shows it. And the other thing is that the graphics are generated independently outside of the report in a little folder. So I do this all the time. I take the charts that PAL generates and I like insert them on Word documents and put them into Excel sheets and all sorts of things just to, like, you know, if I want to have a nice quick chart of a bunch of different counters. So let's just walk through what actually PAL looks like. So let me see here. Let me get out of PowerPoint for a sec. Okay. And I have PAL here already open. So something to keep in mind is that my desktop here is 1080p, and PAL was really written not as a super tool that takes all the screen space here. It's more like a wizards type of tool. So that's why it has like a bunch of empty space here on the side. But what we'll do is I'll just be using Sumit. So as we go through the different tabs here at the top, so you can see if you just follow each tab in order, it kind of walks you through the entire process. So it has this counter log, threshold file, some questions to fill up, how you want to output, where you want to put the file output, if you're going to queue a bunch of files, and then just executing there if you see like the options right here at the top. Okay? So let's go through each of those one by one. So first thing is, if you already have your counter file, the one that has already been captured for many days, you can actually just put it here, and you can pick if you want a restriction on the time, like I said, then you can restrict it here. And then we'll go through this with an actual real file after I go through each one of these options. The thresholds, like I said, you can apply more than one thresholds. So as you can see here, I'm using this one called System Overview, but there's many more. So let me just go here and zoom in, and you guys can see just a snapshot here of all the different files, threshold files that are already included when you download PAL. Okay, so you see here, it's got link, SharePoint, project, a bunch of different SQL Server versions, system overview, VMware, and so on. Okay, and then we can also edit these threshold files as well. So if I click, let's say, edit, and right now I have the system overview selected, so we can see this one actually collects a bunch of info based on process. So process privilege time, a process processor time, and whatnot. And you can actually click on these, and for example, we can see that for this particular one, the thresholds are 50% of overall processor time usage, you see it here, and 75% of overall processor time usage. And you can edit these, right? So I can click here and edit. Now for the editing part, it is PowerShell, so if you know a little bit of PowerShell, it'll probably be even better. If not, usually it's easy enough to read that you can, you know, kind of wing it on your own. You can see here, for example, the 50 threshold is right there on this line. And if, let's say, there's another one that says 75, you could edit it again, and then you can see this, the 75 right here as well. Okay. So again, very customizable. And if I want to actually add things, I can also add. So you guys see here, I can just say, well, I want to do a new analysis. I can browse counters and then go and select any of the counters on my machine. And let's say I want to add some network adapter info to this guy. And say, hey, all the instances, I want to be capturing bytes received per second, just as an example. And then I can click here, add. And the whole thing gets populated here. It actually brings in the description of the counter. And then I can say OK. And now this particular template, if I were to save it, is going to be tracking not only the process, but it's also going to be tracking now the network adapter that I just added. Okay. So again, very, very customizable. I can pick the counters that I want on it, and I can edit them as well. Okay. Now, depending on the threshold file that you pick, there might be some questions to answer. It really just depends on what it says. So in this case, let me see the threshold file assumption. So let's see if we have some questions here. Yeah, and these don't show up unless I like resize the application. So you guys can see here I have some questions. It's asking me what's the type of OS, how much physical memory does it have. So you just have to answer those questions as part of the analysis. And these questions are defined inside the template file. For the output, the only really option that's important here is the analysis interval. So if you see here, you can actually select the different slices of time that PAL is going to use to go through and generate analysis. Because remember, it's going to do averages and max and minimums. So by default, if I leave it to auto, it's going to read the entire log and then split it into 30 time slices. But that might not be what you want, right? So maybe you want it to be by hour. You want to see average, min, and max per hour. So you can actually select it here. Let me zoom in again so you guys can see all the different options. So if you do something like 10 minutes, the report is going to be really big because let's say you selected 1 day, you traced 1 day of activity, and then you have your report by 10 minutes, you're going to get a ton of time slices. If you do that, but then you do something like 1 hour, then you're going to get 24 time slices in a day. Or if let's say you had a day and you just leave it to auto, then it's just going to take the 24 hours, divide it into 30 chunks, and that's going to be your time slice. Okay. Then here's the just pick the path where you want to update the file, output the file, sorry. If you want to put more than one file, you can actually add or remove items from a queue here. And finally, if you want to just execute, or you can add a file to the queue, or you can actually execute and restart if you want. You can actually also adjust how many threads you're going to use to run this analysis. Nowadays, something that I like to do is to just spin up a VM in the cloud and run PAL on it, and then as soon as it's over, I just destroy the VM, which I find very efficient cost-wise. All right, so that's pretty much what it looks like. Now I'm going to show you guys here. This is the website. So this is, like I said, it's pal.codeplex.com. You can download it here. It's on Codeplex, so there's I'm not sure if you need to sign in or not. If you need to sign in, it's free anyway, so it's not a big deal. The download is just a very small installer, and that's pretty much all you need. Okay. All right, so let's finish here the slides, and then we'll go in through all the different PAL examples that I have for today. So use cases for the tool and that you can use with Perfmon and PAL. Well, if you want to collect a healthy baseline, like I said, it's good to collect it even on a healthy status. So if things go south, at least you know what healthy looks like. If you are going through an issue, definitely collect the baseline so that you can now compare it against your healthy one. If SQL Server is innocent or guilty of causing an issue, very useful for that as well, to see if SQL Server indeed is the cause of slowness in a very, let's say, an application that has multiple tiers. If you want to do some before or after analysis, again, you can do it very easily. And if you want to analyze very specific parts of the system, either hardware or SQL Server itself, for troubleshooting or capacity planning, like I said, you can pinpoint on counters related to data, you can pinpoint on counters related to CPU, you can pinpoint counters related to very specific features of SQL Server, like let's say in memory and so on, right? Now the only thing I'm going to say is yes, like I said, many third-party tools do something similar, but it doesn't mean that getting familiar with PAL is not a worthy exercise. For example, it could be that you want to do something very, very specific and your third-party tool is not as flexible to do it. Some third-party tools, you'll be able to accumulate some data, but once you accumulate a lot of data, they start getting a little bit more sluggish and whatnot. So maybe if you want to keep a baseline from, let's say, years ago where you captured when the server initially went online, well, you can just easily run a Perfmon trace, analyze it with PAL, and just save the PAL report. If suddenly somebody needs you to do this type of analysis and it's on a system that's not covered by the third-party tool license, well, then PAL will get you out of that trouble. And if you're a consultant or an independent professional, maybe your client doesn't have any third-party tool and you've been thinking of how to do this for a while, well, this is a good avenue to consider. Okay. So let's go through the demos and see the specific stuff that I've done with PAL. So I'm going to show first a general baseline report. Then I'm going to show a before and after that I analyzed thanks to PAL, and then an analyzing disk I/O situation example using PAL as well. Okay. So first I'm going to show you just the general baseline report. So I'm going to go back here to the browser. This is the HTML report style output that PAL will generate. So the first thing at the top you guys can see here, it'll say alerts by chronological order. So it'll take the time covered by the log, and like I said, splice it into all these different time slices, and it'll tell you if there were alerts or warnings on any given time slice, right? So if we see here on mine, for example, that's the first time slice either. If you go there, it'll give you an output of all the different counters it captured during that time slice, and it'll mark in red the ones that actually caused an issue, right? So we can see here, for example, in this particular time slice, I got an alert of more than 80% CPU utilization, so it's marked red here by PAL, okay? Now, after that all the time slices are done, it actually starts just a list of all the different counters that it tracked and some of the analysis that it did and a chart for each one. So let's see, for example, here logical disk. You guys can see that some of them will say alerts, and alerts, let's say, for example, this one says 8 alerts that are red and 6 that are just like mild. And you guys can see also some of these, like this transfers per second, which is IOPS, where it's stats only. So the reason why some of these are alerts and the other are stats only is because the ones that say stats only, they don't have any thresholds defining what's good and bad. And it's pretty appropriate for example, in this case for IOPS, because we don't really know in general what's a good amount or a bad amount, right? That's a counter that is usually just baseline, and then you have to compare to see if it's good or if it's bad, right? So there's the difference here between the ones that will say alerts, they do have thresholds associated with them, and the ones that just say stats only, they don't have thresholds associated with them, right? And it'll just scroll down, and it just goes through the whole thing. So logical disk, memory, all the different objects that are tracked, and then we go into the SQL Server part of it. So we have SQL Server, buffer manager, general stats, latches. This was generated with the default SQL Server template that is already a part that comes with the PAL tool. Okay, so let's just jump over to some of these counters, and I'll show you what the output looks like then. If let's say we go to logical disk, then we see here a measure of taking the queue length and the amount of latency and whatnot. So this is a formula that came included with the SQL template. It's called here disk overwhelmed, and it just charts it as well. After it's charted, it also gives you the overall stats. So let me zoom in here. You guys can see here at the bottom. It gives you the overall stats for each of these the counters that we tracked, and it gives you min, average, max, the hourly trend deviation, the standard deviation of the counter and whatnot, right? So if we see something like free space usually doesn't change much, so you get just really straight lines here as you would expect. Here, let's say, for example, this is a very useful one, so latency of a disk when reading. As we can see here, let's say, let me zoom in, we can see, you know, the C and D and the overall counter stats. C and D have maxes that are pretty high, so you know 51 milliseconds to do a read is pretty high, but this is a max, right? So if we look at the average, it looks like, you know, average we're not doing too bad, about 4 milliseconds, 3 milliseconds. So I don't usually focus too much on spikes because the spikes can be really misleading. I try to focus mostly on the averages that the tool shows, okay? So, and again, this whole thing will just be, it's a big report. The different counters already come with descriptions that you can read and try to understand what it's trying to tell you, what is low and what is high or not. And if you want to customize your own analysis, I usually, for example, take advantage of the charts, and also the overall counter statistics are really useful for like a quick glance, try to figure out if there's an issue specific to your system. Okay, I'll show you guys something real quick. So when you generate the actual report, you'll get an HTML file. So you guys can see it. I have it right here, my HTML file. And it also outputs all the different charts as images inside a folder that it's in the same place as the HTML file. And these are all output as PNGs. So you can, pretty much just take them and import them into Word if you want to do like a nice Word document, or you can import them into Excel if you want to do some other type of analysis. So I'm going to show you guys what I've done, for example, for some of these. So let's say this is a scenario. This was a before and after type of scenario where a server RAM was downgraded by half, so a little bit even less than half. So a client had a server at 128 gigs of RAM, and they had the suspicion that they didn't need that much RAM, and they could have just released it back to the hypervisor and reuse it for another type of VM and get some good value from that. But then when people do these type of changes, when they're taking away capacity, it's always kind of scary to think, oh, well, am I like going to kill the system because I'm taking away capacity from it? So what I did is I ran just the SQL template of the PAL comes with on the system before they did the downgrade, and then we ran it after, and then I just picked some of the critical memory related counters to show them if it was any difference or not. So it's pretty interesting. Like if we go to the page life, so hopefully you guys can see it here. So page life expectancy, since we have less RAM, the actual value, the absolute value of page life had to go down. There's just no way around it because obviously you're having to deal with a less amount of RAM. But the important thing was, is it actually causing an issue? Now, if we only had the after and we wanted to analyze it, if we look at the, I'm sorry here, I have the GoToMeeting controls on the way. If we only wanted to look at the after analysis, if you guys can see, there's dips here all throughout the day where page life drops, right? So if we only had this counter to go by, we could have said, oh man, no, like the downgrade actually caused the big issue. Now we're getting all these drops during the day. Maybe we should go back to having 128 gigs of RAM. But turns out because we had the before as well, even when we had 128 gigs of RAM, we still had these drops during the day, right? So in this case, we were able to determine, okay, there's still an issue. Actually, we discovered an issue here with the server and why it's, pretty much just dropping to very, very low PLE values during the day. But it's actually unrelated to the fact that we decreased the amount of RAM in the server, right? Lock weights, really easy. We were able to tell, well, no, the amount of the decrease in memory did not affect the lock weights on the server. The charts are pretty much like identical. The plan cache, which is another big consumer of memory, was not affected at all. You can see both of them very, very similar as well. Memory grants was 0 before, it was 0 after, no impact on that. CPU, just some isolated spikes during the day, but there's nothing, it's not like suddenly it's burning tons more CPU. And then requests per second, we could see that pretty much, it was unaffected as well. It's not like suddenly we were slowed down and processing a lot of less requests per second than we were able to do before. So for example, for this type of analysis, we were able to say like, yeah, it was good. We downgraded. There's nothing about it, but we actually just discovered this other issue that is not necessarily related to the downgrade. But if we didn't have the before image, we might have thought that it was related to the downgrade. Okay. And finally, before we finish off today, just want to show you guys this one is an analysis of disk latency done again through PAL. So I just created a template on PAL that included a bunch of disk counters. And then we can see, for example, read latency here. So read latency, if you look at the chart, it's just a bunch of really spikes during the day, and we can see that, again, I took this from the PAL report, the averages are pretty low for read, but there's definitely really big spikes for max. Like if you look at, for this particular drive, we're talking about like half a second just to get a read. So, it's not super bad because of the average, but the spikes seem to be really, really high. Now when we look on, let's say, write latency, then we can see that suddenly it's not just spikes, right? There's like big periods here where it's just the whole thing is going up. And if we go and look at the overall counter stats, we can also see this is reflected on not only a very high max, this is a max of 41 seconds, but we also see that the average for here, for this particular drive, it's pretty high as well, right? We're talking about 60 milliseconds or so, so that's pretty high. Here, this was a machine that was built on AWS, so we were able to see that on spikes we were close to the actual bandwidth capacity of AWS. Same with the IOPS, so this particular AWS volume was set to 3K tops, and we could see that, you know, some of our spikes really approach the 3K per sec IOPS limit as well, so it's something to keep an eye out for capacity planning. Okay, so that's again the type of very detailed analysis that you can do based on Perfmon, and then very easy to analyze. You just boot up PAL, you consume the file, and you can take the charts, take the overall counter stats. If you don't want to overwhelm people with a huge HTML report, I do this all the time. I just create an Excel sheet and I put the stuff that I'm interested in, and it really just gets the point across of the analysis. Okay? All right. Now we'll leave some time for questions, so it's good. So recap, good practice, collect a healthy baseline of the system. If you've never done this before and you have one SQL Server that is really important in your responsibility, then I would advise, you know, take advantage that you saw this today. Go download the PAL tool, download the SQL. Take a look at the SQL Server templates that already come with the PAL tool. If you want to add some counters to that template, go ahead and add them and save it and keep it as your default template, and just collect a healthy baseline of the system today. Like I showed you there, PAL is really easy to use just to collect and process the Perfmon. So it's not just about capturing it, but then about analyzing it. Really easy to just, you know, consume a file and apply a template to the analysis, and that's pretty much it. And then you get that HTML report and all those charts. Like I showed as well, with the PAL reports, we can do performance comparisons like before and after system changes. If you're doing some troubleshooting, if you're doing capacity scenarios there, for example, like I showed with the disks reaching close to capacity on spikes. All of that, I mean, like I said, it's just a matter of creativity and learning what counters you really need to be looking at, and then doing the actual analysis and generating the charts and the averages, the minimums, the max, all that stuff is really easy with PAL, right? And just take those existing templates and and customize them for your needs. So the tool is really easy to use, and like I said, I use it all the time. I add or remove counters all the time from the templates just to have something exactly for the scenario that I'm trying to analyze, and then analyze it and then reuse the charts either directly with the HTML report. If I'm like talking to somebody that's very technical, I might just share the entire thing. But if not, then you can do something like what I showed there on Excel or with Word and just take the charts, the overall counter stats, and use those to drive your points across. Okay? So I think we still have a couple of minutes, which is good, in case we have some questions before we finish up.
We do. Okay, let's start off on the top. I have seen issues where filter drivers have caused issues but encountered resistance because I didn't have anything quantifiable. What sort of counters are recommended for tracking filter driver activity or filter driver performance concerns?
Oh, I'm really not familiar with what counters we could use for that. I would have to go and check, you know, what does Windows offer really in those type of scenarios.
Okay. Let's go to the next one. For disk counters, do you look at logical disk or physical disk? And is it different for VM and or SAN storage?
So I always look at physical because I find that logical is just kind of confusing, right? If you have like a partition disk, even though it's one physical device, it's going to show me multiple logical ones, and and I just don't find that really useful for the analysis. So yeah, I usually always look at physical disk. As far as different from VM or SAN, I do the same analysis for both, and then I figure out what exactly it is telling me with whoever is the admin on the other side. So if let's say we have a VM that just does like raw device mapping to the SAN, then I'll take the numbers and I'll try to speak to the storage admin and correlate those numbers there. And if it's something even simpler, it's just a VM with a bunch of virtual disks, then we have to try to do a little bit of troubleshooting there, as in like, oh, okay, so all these virtual disks that are having issues, might they all be sitting in the same LUN in the storage? And then you have to do some correlation there. Um, but in general, I capture the same thing, and then the next steps are what might be different depending if it's a VM or if it's SAN, and if it's a VM that has like raw device mapping, or if it's a VM that just has regular virtual disks. Like that's where you again have to put your creative cap and see like, is there a correlation? Like let's say different virtual disks have spikes at the same time or showing high latency at the same time, then that might give you a hint of where to take the investigation next.
Great. Okay. Any way to capture the information that the Windows Resource Monitor shows, thinking specifically the IOPs and megabytes per second that is shown at the individual file level granularity?
Oh, that's a really good point. I'm not sure if that, I'm sure you can be able to capture that, but I'm not sure if you'll be able to capture it at the file granularity from Perfmon. That might be something though that you could do with something like Xperf. So Xperf is a completely separate tool that allows tracing at an either lower granularity level than Perfmon. So Perfmon, for example, we're talking about latencies, or we're talking about percentage of processor time, or latencies at the disk level. With Xperf, you can catch CPU processor time, not even by process, but like actual calls inside an executable, right? So I would say look into Xperf, XPERF. There's actually a lot of good material online for Xperf and SQL Server. A lot of MVPs have done material on how to use Xperf to profile a specific CPU consumption by specific methods and modules inside SQL Server. So it's really in-depth troubleshooting. I suspect probably if you want to track something down to the individual file level, maybe Xperf will be able to do that just like it does it at the individual internal CPU level. So I would recommend looking into Xperf. Yeah, it might be the one that could do that.
Cool. Okay, that's great information. How does PAL affect performance if run during production hours?
So PAL, well, that wouldn't be PAL, right? So PAL, you would run it in another system completely unrelated to the actual machine, because you just have to be, you run Perfmon, you capture with Perfmon. Perfmon just gives you a file full of the counter values, and then you just copy that file over to another machine, and you run PAL, and then PAL would analyze it. So PAL, just like I said, I usually run it on a VM that I boot up, copy the counter file, run PAL, analyze it, and then destroy the VM and forget about it. Perfmon itself, I found it to be very unintrusive and almost with zero overhead. If you are on a super, super sensitive system that you're not allowed to put not even one single microsecond of overhead to, then you can also use Perfmon remotely and capture remotely. But I usually don't even bother with that because I found, like I said, the Perfmon overhead, I wouldn't be able to quantify it. I doubt it even goes to, more than 2 or 3%. Even that, I doubt it even goes that high, to be honest.
Okay, perfect. And that answered several of the other following questions, but here's one more. I have used PAL before, and sometimes it fails to open certain Perfmon captures with an error to relog.exe. Have you been able to spot what causes that behavior?
I haven't seen that issue, to be honest. Um, we have to go and like, like I said, if somebody has a recurring issue or something like that, I would say just, I would recommend to go on the Codeplex forum for PAL, and you can probably post it there. The biggest issues I've seen are really, I'm missing some sort of um, like a .NET framework version that is needed for PAL or something like that. But anything other specific than that, I have found though that I get better luck with CSV trace files than from the binary ones. So from the binary ones, sometimes I would get some strange errors, maybe something like that, and I just don't remember. But I do have like it's supposedly be able to read both formats of files. But now that somebody mentions that the kind of unexpected errors kind of thing, I've had better luck by just always generating comma-separated value files from Perfmon, and then consuming CSVs with PAL. But
Okay.
if, like I said, if it's that's just my general tip. But if it's a specific error that you keep getting, I would say just go to pal.coplex and follow the discussions forum there and post your issue.
Yep, good idea. Good idea. Okay, great information, Warner. We have covered all our questions. This recording will be available in the virtual performance chapter within a week, and also the announcement of the winner for the gift card. And if you have any questions, please reach out to the virtual performance chapter or Warner. And we hope to see you in Summit. The registration code, discount code is in the chat. Hopefully you all got that, and we'll see you in Seattle until next month. Warner, thank you so much again,